Okay, day 2, module 10 on sectors. Again, our learning goal for this is to find the length of the arc. So that's our learning target. Our success criteria is going to be to calculate the length of those arcs. And so we'll go over some vocab, make sure you guys are good with that as well as we go through this here as well. So here we go. Looking at arc length again. So I'm going to so you know what we mean by arc length, we're going to refer it back to circumference to start with, and then we'll get into arc length. So you guys have learned previously that the circumference of a circle is like the perimeter of the circle, so it's the distance on the outside of that circle. And we find that by using this formula 2 pi times the radius. So the circumference is equal to this formula here. And again, that radius is half of it, diameter is the full length. So this little diagram should help you with that. So let's just make sure you guys are good with finding the circumference. Again, we're just going to use this formula using the diameter of the radius. So if I'm given the radius, all I have to do to find the circumference is go 2 pi and then times it by, again, 6 is what I get for that, okay? And then when I'm done with that, that gives me my circumference. So this is 37.70, and it's centimeters when you round it, okay? If I just look at this next one, I have to half this 47 first. So I have to half this to get my radius, which my radius will be 23.5. And then to find my circumference, I'm just going to go 2 pi times 23.5 is what I'm going to do with that. And when I do that, I get, again, 147.7 feet when I round for that one. So same thing with story problems. If I have a soda prop or soda can that has a radius of 1.5 inches, and I want to find the circumference of the top of that soda can, it's just going to be, again, 2 pi times 1.5 will help me because that's the radius for that as well. So, and that gives me, again, 9.4, and that's going to be inches as well. So, okay, a couple other things. We should be able to find the radius if we're given the circumference. So if I'm given the circumference is 43, I mean, think about this, guys. That's equal to 2 pi r. So to solve this, I have to divide this by 2 and then by pi. So I'm going to divide this by 2 pi. But remember, it has to be all together down here. So the bottom part's got to be that way. So 43 divided by 2 pi. And when I do that, that one gives me a radius of 6.84. Okay, for this one, again, I'm going to go 97 equals 2 pi r, so I've got to divide by 2 pi. So this would be r is equal to, again, 97 divided by 2 pi, and that gives me 15.4 is what I get for that one. So you got to be able to work backwards. Okay, so that's circumference. Let me tie in with arc length because that's our big goal today. So arc length is just going to be a piece of the circumference. So that's represented by this L on the outside. Again, if I highlighted that, it would be this red part right there. It's that length right there. Okay? And so there's two ways about doing this. There's a formula you can do in degrees, which this one would be the degrees one. Or you can do it with radians. So you got to convert it to radians, which it's about 6s for either way. Again, if you do it for degrees, it's just the degree measurement divided by 360 and then times by 2 pi r. So you're taking a fraction of that. Okay. If you're doing it in radians, the radians is just going to be, again, I'm going to use this theta times r. And the theta is, this is going to be your angle in radians. So you're converting that. And then this would just be your radius. So I'm going to use, for me, I'm going to use this formula right here when it's in radians, not when it's in degrees. Okay, but you can use the degree one if you'd like. Okay, everybody kind of clear with that, hopefully. Again, I'm not using this one right here. I'm using this one where it's in radians. And again, if I drew my circle, it would be this way. This would be r, and this would be theta, but it's got to be in radians. Okay. So example number 1, if I have this, there's my radius, I've got to convert this 80 degrees into radians. So remember, all I'm going to do is times it by pi and divide it by 180, and that is my degree in radians. Okay, and then all I do is take that 80 over pi, or 80 pi over 180, and times it by 7, and that'll give me my arc length when it's all said and done. Okay. So calculate that. I get 9.77, and that would be my arc length, or the piece of the circumference. Okay, so if I look at this number 6 here, I'm going to go 60, and then I've got to times it by pi over 180 because I'm going to convert that to radians, and then I'm going to times this by 9, and again, that'll be it for that. And when I do that, I end up with 9.42. So that would be my answer for that one. Okay, this one's multiple choice, but again, I'm going to take the angle and convert it to radians, so times it by pi over 180, and then I'm going to times it by 5 once I'm done with that. So times it by 5, and that will give me 7.9, so that would be my answer right there. Again, 7.85, blah, 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 which would be 7.9. So that's how you find arc length, guys. You just take the angle, you convert it to radians, and then times it by the radius. Okay? So this next one, let's say I've got a clock that's made up of 12 pieces. This is a good story problem. The radius is 3 inches, so we need to know that, and we want to know the shortest distance between the two numbers. So this first one, I want to know the shortest distance. Again, if I highlight this one from 3 to 8, so that's going to be this distance right here. Again, my radius is 3. Okay. So what I need to know is what is this angle is what I need to know. Because once I know the angle, then I'm good. Well, guys, this full circle is 360. Right? Full circle is 360. So I'm going to divide it by 12. And when I divide it by 12, that'll tell me what each piece is. So each piece is 30. So I've got 1, 2, 3, 4, 5 pieces. So I put 13. Each piece is 30. So if I have 5 pieces, 5 times 30 will give me 150 degrees. So this is going to be 150 degrees here. So to find the arc length, again, my degree is 150 degrees, but remember I'm going to times that by pi over 180, and then I'm going to times that by the radius of 3, and that'll give me my value that I have. So let's do that right now. When I do that, I end up with 7.85 is what I end up with. So that would be how far that distance is in the red. Is what I get for that one, okay? All right, the distance between 3 and 4, so that would be from there to there, or this part that's in green. That's just one section, so that's a 30. Again, one section times 30 is just 30. So this would be a 30 degree that I need to convert. I'm going to times it by pi over 180, and then times it by 3. And when I do that, I get 1.57 is what I end up with that one. And then my last one here, it wants from 135. We're going to assume that those arcs. So 135, that'd be at 1. and then at 7. So we'd have a there, and we want the distance around here in blue. So that would be 1, 2, 3, 4, 5, 6 sections times 30, which would give me 180. So I need to know, again, 180. I need to convert that and use that one. So I'm going to go convert it by times it by pi over 180, and then I got to times it by 3. So this should just be 3 times pi, which would give me 9.42 is what I'd get for that one. Okay, so that's how you find arc length. You're just going to use this formula, the angle in radians times by pi. So, all right, we'll see you.